Alright, and welcome to Solving 3x3 Systems Level 3. Now, in our very first example, there's a very easy way you could do this. You could actually cancel out your y's. We can see that there's a positive y and some negative y's, and that would actually be really easy. However, I want to introduce you to the idea of row manipulation, or we could say row multiplication. And let's see what I'm talking about here. Let's go ahead and call this one row 1, row 2, and row 3. And I actually want to use my row manipulation to cancel out my z's. Okay, so let's go ahead and draw our little t-chart here. Give ourselves some adequate space. And I noticed that for row number 3, there's actually a 1 in front of that z. So that's going to be pretty handy. Let's use that. Let's say, hey, we're going to multiply row 3 by some number, and then we're going to add it to row 1. And because it's a 1, we can actually use this twice. We'll use row number 3 again, and then we'll add it to row number 2. Okay, so let me go ahead and write this out, and let's see here. What would this look like? So row 3 has a 2x minus y plus z equals 4, and row 1 is x minus y plus 2z is equal to 4 as well. Okay, and I want to cancel out my z's. So my question that I'm asking here is I'm saying, you know what in the world cancels out a positive 2z? Well, I know the thing that cancels out a positive 2z is in fact a negative 2z. And so the question I'm going to ask is, what can I multiply positive 1 by? What can I multiply positive 1 by so that 1 times something gets to negative 2? Well, 1 times negative 2. And in fact, I'm going to fill this in, so I'm going to multiply my whole row 3 by negative 2. So I have negative 2 times 2x, which is negative 4x. I have negative 2 times negative y, which is a positive 2y. I have negative 2 times 1, which is this negative 2z. And I have negative 2 times 4, which is equal to negative 8. And it's now that what I can do is I can, in fact, combine my original row 2 and my manipulated row 3, and let's go ahead and combine these. Let's see what you get. X, this is really 1x minus 4x is negative 3x, and I have a negative 1y plus 2y, which is a positive y, and I have 4 minus 8, which is negative 4. Perfect. And this is kind of like a new completely different row. Okay, so we'll kind of keep that right there. And let's go over to our second portion. So I say, okay, I have my row 3 again. So that's going to be 2x minus y plus 1z is equal to 4. And my row 2, which is in this case 2x plus y minus 3z, which is equal to 0. Okay, and so the question that I'm going to ask here is I'm going to say, you know what is the opposite of negative 3z? What gets rid of a negative 3z? And the answer is, of course, a positive 3z. So I'm going to say, well, okay, I have a positive 1, and what in the world can I multiply positive 1 by so that 1 times something gets to positive 3? And in this case, I'm going to do 1 times 3. Okay, so I'm going to multiply my whole row 3 by 3. What's that going to give me? 3 times 2x is 6x. 3 times negative y is negative 3y. We have 3 times 1z, which is that positive 3z. And we have 3 times 4, which of course equals 12. Now at this point, what I can do is just add straight down. I have 2x plus 6x, that's going to be 8x. I have 1y minus 3y, which is negative 2y. And of course my z's cancel out, and I have 0 plus 12, which is 12. Now at this point, I have two 2x2 systems, and this is where it gets a little tricky. So what I want to do, if I understand this, I see that there's a 1 right there, so this is going to be very easy to manipulate. Let's bring this 8x minus 2y equals 12. We're going to bring it under here, and now we have a 2x2 system, and we can actually solve these pretty easily. So kind of the same rules. I say, you know what gets rid of a negative 2y? Well, a positive 2y. Okay, so the question becomes, what can I multiply positive 1y by 1 times something gets me to 2. Well, 1 times 2. And then I'm just going to manipulate this new 2 variable equation. So say 2 times negative 3x, which is negative 6x plus 2y. And then we'll do 2 times negative 4, which is negative 8. And then let's just go ahead and add straight down. So I know that 8x plus negative 6x is in fact 2x. And this, my y's cancel out. Now I have 12 minus 8, which is of course 4. And let's just write this over here. We have 2x equals 4. And you know what to do. To get x by itself, we can divide both sides by 2. And I'll just kind of copy this up here. X is equal to 2. All right. So like, what were my steps? My steps were multiply row 3 by some number so that my z's canceled out. Multiply by row 3 by some number so my z's, oh, I'm sorry, not my z's. Yeah, so my z's canceled out. And then from there, I took this 2 by 2, this 2 variable equation and this 2 variable equation, and then I stacked them on top of each other and I just solve again. Now at this point, what I want to do is I want to take this single variable, this x that I found, and I actually want to plug it into one of my 2 variable equations. So since I've got a little bit of room over here, let's just go ahead and plug it in over here. I can say, you know what, we have, switching colors again, we have 8x, remember I know what x is, minus 2y is equal to 12. And I'll just take my x value, this positive 2, and plug it in. Okay, so I have 8 times 2, which is 16, minus 2y is equal to 12. And then we just do a little solving. You can subtract 16, you can subtract 16, and what's this going to give us? I'll kind of squeeze in over here. That zeroes out. I have negative 2y is equal to, and let me just go ahead and erase that, get rid of that. Okay, and 12 minus 16 is negative 4, and then just divide both sides by negative 2, and check it out. Negative 4 divided by negative 2. Now we have y equals positive 2. Nice and easy. Okay, cool. So let's go ahead and kind of pause this, and I want you to clean everything up. But the big idea that I'm about to introduce to you is once we have x, once we have y, we now are going to go ahead and take one of our 3 by 3 equations and plug x and y in to find our final value, z. Pause this, finish taking all your notes, and let's get to it. Okay, as I look at my row 1, row 2, and row 3, I'm actually going to choose row 2, and the reason I want to choose row 2 is because it has that 0. 0 is always a really nice and easy number to work with, and yeah, why not? Why not make life easier? So, I know my x value, I know my y value, I have my minus 3z, remember we don't know what z is, and this all equals 0. And from here, let's plug in our x value of 2, let's plug in our y value of 2, and of course 2 times 2 is 4, plus 2 minus 3z is equal to 0. Well, of course, y'all know what 4 plus 2 is. That's 6 minus 3z is equal to 0. And we'll just solve. We'll subtract 6 from both sides. Now I have negative 3z is equal to 0 minus 6, which is negative 6. And we'll divide both sides by negative 3. And check this out. Z is also equal to positive 2. Okay, so it's almost like I planned this out. And so our answer is really 2, 2, 2. Remember, because our solution is always x, y, z. Now, you might be looking at the time here and you might be thinking, okay, Mr. Hastings, this is a very long video. This is like an 8 or 9 minute video at this point. I know that these are difficult when you're first working through them. So I'm actually going to shoot one more example, and it's really up to you to gauge, do you understand this or do you not? And if you don't understand this, then you need to watch the second example, but I'll have this caveat. It's okay to take a break. So pause the video, go take yourself 10, 15 minutes, come on back, and let's get to it. Okay, here we have example number 2. So let's go ahead and say, when I look at this, there's no easy rows that cancel out. So this one is a pretty tricky one, and we're definitely going to have to use row manipulation. And so I think, as I look at this, I think the best one for us is let's just go ahead and practice out our y's. And the reason I say that is there's still a negative 1 right here. So that negative 1y is pretty nice. We can go ahead and kind of start to set up our table. Oh, and you know what? What did I not do? I didn't label this. We have row 1, we have row 2, and we have our row 3. Okay, so we know that row 1 has this negative 1, which is very handy. So we can do parentheses row 1 plus row 2 and parentheses row 1 plus row 3. Okay, cool. And so let's go ahead and write these out. So for row 1, I see that we have, let's switch colors here so it really pops out. We have 2x minus y plus 3z is equal to 7. And we have our row 2, which is going to be 3x plus 5y minus 2z is equal to 4. Okay, and so you know what? I always draw that line one step too early. My apologies. So what we want to do is we want to get rid of a positive 5y. So you ask yourself, okay, well, what gets rid of a positive 5y? The opposite of a positive 5y is, of course, negative 5y. And so we're going to go up here and say, well, you know what? We have a negative 1. So negative 1 times what number gets me a negative 5? And obviously negative 1 times positive 5, because we want to keep the sign the same. So we're going to multiply our row 1 by 5. Okay, so what's 5 times 2x? Well, 5 times 2x is going to be 10x. Okay, we have 5 times negative 1y, which is this negative 5y. We have 5 times 3z, which is, of course, 15z. And we have 5 times 7, which is 35. Okay, perfect. All right, now what we want to do is we want to add these two rows straight down. So 3x plus 10x is 13x. 5y minus 5y, that zeroes out. And negative 2z plus 15z, well, that's going to be plus 13z. And this is equal to 4 plus 35, which is 39. Now, I'll be honest, I think I did a bad job of lining that up from here to here when we combine it. So let me do a little bit of a better job on the other side. Okay, let's go ahead and go with this nice magenta color. And let's go ahead and write our row 1 again. We know that it's 2x minus y plus 3z is equal to 7. And our row 3 is going to be this 5x plus 2y minus 5z is equal to 13. Okay, perfect. And what we want to say is this. Since we canceled out y's over here, we have to cancel out the y right here. And what gets rid of a positive 2y? Well, a negative 2y. So we go up here and we say, okay, we have a negative 1y. And the question is, negative 1 times what number gets me a negative 2? Well, negative 1 times 2. Yeah, that's nice. Okay, so 2 times row 1 plus row 3. Well, what does 2 times row 1 really look like? 2 times 2x is 4x, and 2 times negative 1y is that negative 2y, and 2 times 3z is plus 6z, and 2 times 7 is going to be plus 14, and now we can just add straight down. So I have, let's use a different color here so this really pop. 5x plus 4x is 9x. My y's cancel. And negative 5z plus 6z is really positive 1z. And 13 plus 14 is 27. Okay, so I think this might be the point where if you did get confused in the last example, you got a little stuck. We now have a 2 by 2 system. And what we can do is we can take this two variable equation and put it over here. 13x plus 13z is equal to 39. Now what I want to do is I notice that I have a positive 1z. Remember, positive 1z, that's so easy to work with. So the question is, well, how can I get rid of a 13z? And the opposite of positive 13z is negative 13z. So I'm going to say, you know what in the world, let's block that off, can I multiply positive 1 by to get to negative 13? I can do positive 1 times negative 13. And here I'm going to have to use some pretty big numbers, so let's do it. We have negative 13 times 9, which would be negative 9 plus 27, so that must be negative 117x. We have negative 13 times 1, which is our negative 13z. we have negative 13 times 27. And while I think I could do that in my head, let's just go ahead and use a calculator so I don't make a mistake. So negative 13 times 27, and that'll be negative 351. Negative 351. And at this point, what I can do is I can now combine these two rows, and let's see what happens. 13x minus 117x is going to be negative, looks like negative 104x. My z's zero out, they're gone. And 39 minus 351, let's see, 31 minus 351 is going to give us negative 312. Now, if I want to get the x by itself, I can simply divide both sides by negative 104, divide by negative 104, and at this point we have our first x value. Negative 312 divided by negative 104 is simply 3. Whoa. Okay, so a lot of work to get there, but once you get that x value, it gets a whole lot easier. Let me use a wildly different color. Let's use yellow. Because now that I have this x equals 3, I know that I want to plug it into one of my 2x2 equations. So I can either plug it into the 9x plus 1z equals 27, or I can plug it into the 13x plus 13z equals 39. And look, since I have all this room right here, let's use this one. Let's say, okay, we know what x is, so 13x plus 13z is equal to, let me erase that real quick, is equal to 39. And then we're going to plug in that nice yellow. We're going to say, you know what, x is equal to 3. Let's go from there. 13 times 3 is 39, plus 13z is equal to 39. Hey, this is pretty nice, because to get rid of 39, I can subtract 39 minus 39, and when that cancels, I have 13z is equal to 0. Well, that's easy. If I divide both sides by 13, 0 divided by 13 is still 0. So z is equal to 0. Now, here's my recommendation. Please go ahead and pause the video, finish taking your notes, and let's finish this off by taking our 3 by 3 variables, and let's pick an easy one to plug these two variables into. So let's clean this up. Okay, I think I just want to go ahead and use row number 1. It doesn't look too bad. So let's say this. We have 2x minus 1y plus 3z is equal to 7. And we're actually trying to find our y value. So say, okay, well, we know what x is, minus y, plus 3, we know what z is, equals 7. And let's actually plug these in. I know that my x value is 3. I know that my z value is 0. And yeah, let's just work this out. Okay, so 2 times 3 is 6, minus y. And y'all, what is 3 times 0? Well, it's 0. So there's nothing there. And so let's just say equals 7. Okay, how do you get rid of a positive 6? Minus 6, minus 6. And we now have negative y is equal to 7 minus 6 is 1. And we can divide both sides by negative 1. And we get y equals negative 1. At this point, we can now write our final solution. Okay, we know that our x value is 3, our y value is negative 1, and our z value is 0. Nice and easy. All right, y'all, I know this is a long video. Good luck, take your time, and I'll see y'all in our level 4 video.